NVIDIA. The name is now synonymous with the artificial intelligence revolution. But this company wasn't built for AI, it was built for video games. This is the story of how a company dedicated to making digital worlds more beautiful accidentally created the engine for our new reality. By 1993, the personal computer industry was facing a new kind of crisis. The explosion of 3D gaming with titles like Doom, demanding unprecedented graphical fidelity, began to overwhelm central processing units, which were never designed for such specialized parallel tasks. This created a market opportunity. Jensen Huang, co-founding NVIDIA, saw the CPU bottleneck as a chance for a new kind of processor. Meanwhile, Microsoft was developing its DirectX API, a standard that would soon unify PC gaming and create a massive software market. The problem intensified on December 16, 1994, with the release of the first Sony PlayStation in Japan. This dedicated console, with its specialized graphics hardware, demonstrated a level of 3D performance that most consumer PCs of the era simply could not match. This is ExplainCast, where we break down how everyday technology actually works beneath the surface most people never see. Gamers and developers took notice. John Carmack, a legendary programmer at ID Software, publicly advocated for hardware acceleration to push gaming forward. The pressure was mounting on the PC platform to evolve or be left behind by consoles like the PlayStation. To solve this, NVIDIA released its first product, the NV1, on May 22, 1995. It was an ambitious but flawed attempt, combining 2D graphics, 3D acceleration, and audio on a single card. Its use of quadratic texture mapping proved to be a critical misstep. The market response was poor. Jensen Huang watched as developers, including those at Microsoft working on DirectX, standardized around polygon-based rendering, making NVIDIA's NV1 incompatible. The company was pushed to the brink of financial collapse, a near-fatal early mistake. Facing extinction, the company pivoted dramatically. On April 6, 1997, they secured a crucial lifeline, a $20 million investment. This funding was predicated on a radical new plan to build a pure, polygon-based 3D accelerator from the ground up, codenamed Riva. This pivot saved the company. Jensen Huang used the new capital to focus his engineers at NVIDIA entirely on the Riva 128 chip. They were racing against competitors like 3DFX Interactive, who had already found success with their Voodoo graphics cards. In late August 1997, NVIDIA launched the Riva 128. It was a powerful, integrated 2D, 3D solution that offered competitive performance at a disruptive price point. The chip was designed to be a brute force accelerator, a strategy that would define the company's future. The market reacted with enthusiasm. Dell and Gateway, major PC manufacturers, began to adopt NVIDIA's Riva 128 chips in their consumer systems. This gave Jensen Huang the high-volume sales needed to fund the company's next, even more ambitious, generation of hardware. The company's next major leap forward came on January 26, 1999, when it was listed on the NASDAQ Stock Exchange. This IPO provided a massive influx of capital, allowing NVIDIA to dramatically scale its research and development efforts for future products. With the new funding, Jensen Huang was able to push NVIDIA to out-innovate its rivals. The company began a relentless 6-month product cycle, a pace that competitors like 3DFX Interactive struggled to maintain, leading to their eventual decline and acquisition by NVIDIA. On August 31, 1999, NVIDIA announced the GeForce 256. The company boldly marketed it as the world's first graphics processing unit, or GPU. This wasn't just marketing. The chip integrated hardware transform and lighting, offloading key 3D pipeline tasks from the CPU. This new GPU architecture had a profound effect. Game developer Tim Sweeney of Epic Games praised the GeForce 256, noting how it enabled more complex worlds and characters in their Unreal Engine. The balance of power between the CPU and GPU began to shift decisively. The next evolutionary step occurred on November 13, 2001, when Microsoft launched the original Xbox. Inside this console was a custom GPU designed by NVIDIA, cementing the company's position as a dominant force not just in PC graphics but in the console market as well. This partnership gave Jensen Huang and his team at NVIDIA invaluable experience in designing high-performance, cost-effective chips for a mass-market consumer device. This discipline would prove critical for their future endeavors beyond the world of interactive entertainment and gaming. A pivotal moment arrived on June 29, 2007, with the launch of the first Apple iPhone. While not directly related to NVIDIA, the rise of mobile computing it heralded created a new class of processors and pushed high-end desktop performance into an even more specialized niche. As mobile chips handled everyday tasks, the desktop GPU, now incredibly powerful, had excess capacity. Researchers like Ian Buck at Stanford University began to wonder if this gaming hardware could be used for general-purpose scientific computing, a field previously dominated by supercomputers. The key breakthrough came from NVIDIA itself on February 15, 2007, with the official launch of CUDA. This was a parallel computing platform and programming model that unlocked the thousands of small cores inside a GPU for general-purpose computation, not just graphics. This changed everything. Andrew Ng, then a professor at Stanford University, was one of the first to see the potential. He and his team realized that CUDA-enabled GPUs from NVIDIA were perfectly suited for training the large neural networks required for deep learning research. A landmark validation of this approach occurred in the fall of 2012. A team of researchers from the University of Toronto submitted their deep learning model, AlexNet, to the ImageNet Large-Scale Visual Recognition Challenge, a major competition in computer vision. Their model, trained by researcher Alex Krzyzewski on two NVIDIA GeForce GTX 580 GPUs, shattered all previous records. It achieved an error rate of 15.3%, a massive improvement over the 26.2% of the next best entry, shocking the AI community. The victory of AlexNet on October 30th, 2012 was the big bang of the modern AI era. It provided undeniable proof that using GPUs for deep learning was not just a theoretical possibility, but a practical and vastly superior method for training AI models. Following this, demand for NVIDIA GPUs skyrocketed. AI pioneers like Yann LeCun at New York University and later at Facebook's AI Research Lab began building their entire research infrastructure around the parallel processing power that only NVIDIA's hardware could provide. The market for AI-specific hardware began to formalize on April 5, 2016, when NVIDIA announced the Tesla P100. This was the first GPU built from the ground up for data center and AI workloads, featuring new technologies like high-bandwidth memory and NVLink interconnects. This move solidified NVIDIA's new identity. Jensen Huang personally unveiled the chip, signaling to investors and the tech world that NVIDIA was now an AI company. Major cloud providers like Amazon Web Services quickly started offering instances powered by these new GPUs. Then, on June 21, 2017, Google published a seminal research paper titled "Attention is All You Need." The paper introduced the transformer architecture, a new type of neural network that was exceptionally effective at processing sequential data, like human language. The transformer architecture, while revolutionary, was also incredibly compute-intensive. Researchers like Ashish Vaswani, one of the paper's authors, found that training these large language models was only feasible on massive clusters of NVIDIA GPUs, further entrenching the company's hardware. Seeing this trend, NVIDIA moved to optimize its hardware for this new architecture. On May 14, 2020, the company unveiled its Ampere GPU architecture, which included a new feature called tensor cores, specifically designed to accelerate the matrix math at the heart of transformers. This hardware innovation was immediately adopted. The team at OpenAI, led by CEO Sam Altman, leveraged the new Ampere-based A100 GPUs to train their increasingly large and powerful GPT models, creating a symbiotic relationship between AI software and NVIDIA's hardware. The AI race reached a fever pitch on November 30th, 2022, with the public release of ChatGPT by OpenAI. The model's stunning capabilities captured the world's attention, demonstrating the power of large language models trained at an unprecedented scale. The success of ChatGPT triggered a gold rush. Jensen Huang saw an explosion in orders for NVIDIA's A100 and newer H100 GPUs, as companies from Microsoft to startups scrambled to build their own AI infrastructure to compete with the capabilities demonstrated by OpenAI. This created a new kind of supply chain constraint in early 2023. The world's capacity to advance artificial intelligence was no longer limited by ideas or algorithms, but by the physical manufacturing and availability of NVIDIA's high-end data center GPUs. The effect was a fundamental reevaluation of national infrastructure. Leaders at government bodies like the U.S. Department of Commerce began viewing access to advanced GPUs from companies like NVIDIA as a matter of economic and national security, akin to oil reserves. The cycle continued on February 21st, 2023, when NVIDIA reported quarterly earnings that far exceeded all expectations. The company's revenue forecast, driven by AI chip demand, shocked financial markets and cemented its status as a central pillar of the new economy. This financial windfall allowed Jensen Huang to direct NVIDIA to invest billions more into next-generation AI hardware and software. This created a powerful feedback loop, where AI success drove NVIDIA's revenue, which in turn funded the creation of even more powerful AI chips. By May 30th, 2023, NVIDIA's market capitalization briefly surpassed $1 trillion. This milestone was a direct result of its strategic pivot from a company serving gamers to one providing the core infrastructure for the entire artificial intelligence industry. This valuation placed Jensen Huang and NVIDIA at the center of the global technology landscape. The company's product roadmaps and manufacturing capacity became a primary concern for executives at every major tech firm, from Google to Meta platforms. As of early 2024, the demand for AI compute continues to grow exponentially. The release of new, more capable models in areas like video generation and scientific discovery is placing ever-increasing strain on the existing global supply of advanced GPUs. This has led to a singular focus within the industry. Leaders like Satya Nadella of Microsoft are now engaged in a multi-billion-dollar arms race to acquire as many NVIDIA H100 GPUs as possible, building out massive data centers dedicated solely to training and running AI models. The future of artificial intelligence, for now, is being built upon a foundation laid on November 30th, 1993, the day a small company was incorporated to solve a graphics problem for video games. It was a problem of parallel processing. The solution, championed by Jensen Huang, was the GPU. It turns out that the same math used to render a dragon in a fantasy world is the math needed to power a neural network. A tool for entertainment became the engine of a revolution, placing NVIDIA at its core. The systems that shape our world are often invisible, built on decades of technological evolution. If you found this explanation of NVIDIA's journey insightful, consider subscribing for more stories about the infrastructure of our modern age. Explore our other videos to understand the hidden mechanics behind the technology you use every day.